My name is Dimitri Oliveira, and on this video, I'm going to do a walkthrough of my submission for the uh, Kaggle Google Gemini Long Context Competition. So my input is this notebook here that I called AI Trailer on how to use Gemini to create video trailers uh, on an automated way. So the idea of this notebook here, it's quite intuitive. So I won't go into a lot of explanations, but basically the idea is to use AI and machine learning to create trailers from videos in an automated way. I have previously done some work on this, so this is basically an extension with small modifications on the initial project just to create a special version of my code for this competition. So on this video, I'm going to do a walkthrough to the code and explaining the process and why I picked Gemini and why I think this is a very good use case that shows why Gemini is much better than other options, especially leveraging its features like the super long context window of 2 million tokens and also context caching that fits really, really well for this specific use case. So to start with, after we go through the dependencies, we can see all the parameters that I have set here that are being used to control which models and how they are going to interact with each other through the pipeline to create a video trailer. Probably the most important ones are these first few. The first one is the input video that I'm going to use to create the trailer here. So you can see that this is using a Kaggle dataset that I have also created and is attached to this notebook in case you want to take a look. The first few parameters here that is uh, related to the trailer creation is the definitions of the model that the Gemini model that's going to use it. So you can see here that I'm using Gemini Pro for this one. And there are a few other parameters that I'm not going to go through a lot of details, but I will explain a few more of them through the walkthrough, like why I'm using caching, the time of caching that I'm keeping in, and following this, I have also the parameters for the trailer improvement here. Notice that I'm using a different model here. Basically, the idea here is that for the initial draft of the trailer transcript, I'm going to use a very powerful model, the Gemini 1.5 Pro. And for the trailer improvement, I don't need a model that is that powerful. So I can simply just pass Gemini Flash that will be much more cost efficient for this second task. The other few parameters are not very important. They are basically related how the trailer will be pieced together and how I'm going to create the voiceover, how I'm going to combine the clips from the movies, and also maybe is also a cool one that is related to the similarity model that I'm going to use to pick the correct pieces of the trailer to fit the trailer that I'm going to create. So yeah, maybe it's a little bit confusing just look at the parameters, but as we go through each one of these steps, hopefully it will become a little bit more clear of how all of this comes together. So after the setup here that I pick my secret key to use Gemini, we can see the diagram of the whole project here and each one of the steps that we are going to go through into a little bit more of detail. So you can see that it comes from the initial part, that is the trailer transcript creation that is built using Gemini, and all of the rest of the steps here that are basically combining and using both the video and the assets generated by Gemini. So basically everything else here is being built on top of Gemini and leveraging its unique, powerful features. Once we move through here, we can see the first step that is the trailer creation, where I have a couple of functions here. Basically, they are just instantiating the model here. I'm using the generative AI studio helper functions using Python to instantiate my model. And you can see that I'm going to instantiate the model slightly different depending if I'm using cache or not. For the first step, I'm going to use cache, but for the second one, cache is not needed. So I'm keeping both of them into a function here. Second function is to upload the file to Gemini. Since I'm going to create the trailer, I need to provide that trailer to Gemini in the same prompt so that it can create the trailer based on that video. Hopefully, this is very easy to do with AI Studio Python library. So you can see here that it's basically this single line of code here that I put the path to the video and pass a video type, a file type. For this case, I'm only using MP4 files, so I'm keeping this as hard coded. But if you want to upload different types of files, you can follow the documentation, and it will be basically the same thing, just switching the MIME type here. After this, we need to have a bit of code here just to make sure that we are not going to go through the rest of the code pipeline without the file being uploaded. So if you're uploading a large file, which will be the case here, uh, maybe it will take a few seconds to upload, depending on the size of the file and also your internet connection. So just wait a little bit here into this loop until the file is fully uploaded. And if nothing goes wrong, we can keep going through. So that would be if the file is not going to be cached, but we also have the powerful caching context feature for Gemini. So it's also very easy. So it's just a single function. If I want to do the caching, I will pass my model ID and I will set an ID here. That would be the video, the file name, and I will also pass the video. So with this, I will like build a specific model that is was cached with a specific file. That is what I'm going to do for the first step here. And then we can go through the prompting of the model that is also very basic. So this is a function that just receives some specific parameters like the model, the video file, and also input prompt in general. And basically everything that is be done important is in this part here that the asks the model to generate the response. So if the model has was cached before, it will be part of its properties, and it will generate response with the cached file. If not, I will just append to the prompt my video file. So it will be quite in Gemini using both the video file and also the prompt. And we can see the full response here on this cell. So you can see the prompt that I'm using to generate the trailer transcript, which is quite simple actually. So it's just basically instructions for the model to analyze the video and create a trailer transcript that is interesting. I'm using here the models that I have shown to you guys and also the configurations that we have seen above. And the output will be looking something like this. So these are the logs here. So it waited a little bit until the file was fully uploaded to the path, which I can see here, just for logging purposes, the path to that file. And we can see some interesting metadata about the file. So the video that I'm going to generate the trailer here, it had like 400,000 tokens. So it's already a big file that would not be able to be processed by other model providers, being mostly open source or even the private ones. So this is already a very big advantage for Gemini. And you can see here, just to debug it and take a look, the trailer that the model created. So you can see that it already looks very good. So each one of these lines would be mostly a scene for the trailer. And this one already looks good. But what I have noticed doing many tests is that sometimes the model generates a little bit of uh, text artifacts, like pre-appending to each one of these scenes. If a narrator tag, maybe it starts with, sure, let me generate the trailer, and then comes the trailer. So usually what I saw that was a big improvement was also to add another step after this initial draft, that is to just prompt the model, another model or the same model, to do some basic improvements of the trailer transcript, which I'm doing here. So it's that prompt that is very similar to the previous one, but it has some specific instructions to avoid uh, scene descriptions and the speaker annotations, and to make it more engaging in general. So after this second step, we can see that the trailer is usually improved. But this one is super short and simple. That's why I'm not using Gemini 1.5 Pro. I'm just using the Flash one, so it's much faster and cheaper. And you can see here the trailer that was improved. Okay, then we can go to the next step, which is the following step is mostly Python code, so they are not very important and not very related to Gemini, but it's also, let's say, important to the final combination and piecing together everything on top of Gemini. So scene split is actually very simple. If I bring up here the diagram, you can see that I'm basically uh, retrieving the trailer that was created before and improved by Gemini and splitting them into scenes. And they are going basically to be splitted by spaces. So each one of these new lines here will be a different scene for my trailer. Okay, so something very simple, quick to run. And then we can go to the next interesting step, which is the voice generation. So this code is very modular. I'm basically using a specific library to do text-to-speech transcription here, but you can plug any model. You can even use Vertex AI text-to-speech code that it's very, very good. Initially, I was going to use it here, but I was not able to use on Kaggle Notebook. But on this same version of this code that runs on Google Colab and also on my GitHub repository, you can find the code to use Vertex AI text-to-speech, which is the best one. It's super fast and the results are super good. But here I'm using a specific library, and the idea is very simple. So I pick each one of the scenes text here. I go through the text-to-speech model, and then I will have a speech version of each one of these scenes. So the code is not super important, so I will just skip through. And you can see the logs here that is generating the audio for each one of the scenes. You can see the syntax here, and then I will get an audio for each one of them. So it just loops through each one of the scenes and gets the audio. The next step is frame sampling, which is a little bit it's quite intuitive, so it's a little bit simple as well. I just get the original video file and I sample a bunch of frames from it that would be used later to do the frame re-ranking. So an explanation that combines both of these steps here is that I get the frames, I get the original video, I frame some samples like 500. I'm using here by default, but you can make it more or less if you want. What I found out is that if I use a very low number, I might be missing some important parts of the code. But if the number of samples is very, very big, it doesn't make like a big difference because maybe once every half of a second you will get a frame, and then the similarity model here it just gets maybe a little bit confusing. It's going to retrieve like a lot of frames that are very, very close to each other. So it's also less efficient here. So there is a little bit of trade-off for this step. And after I do the frame sampling, I go through the frame re-ranking. So my similarity model here, which I'm for this specific case, I'm using sentence transformer. It will uh, rank each one of the frames here that I have sampled for with each one of the scenes here. So in the final, for each one of the scenes, I will have which frame better represents that scene. So yeah, so maybe for this specific scene, there is like a frame in the middle of the video that represents it very well, really well. And then also related to this part, I have the next step that is the clip creation. So this is also very simple and it's mostly Python code. So I will get the the most important frame for each one of the scenes, and I will get a slice of video based on it. So let's say that this first frame here is right at the beginning of the video, and the audio generated here is like 20 seconds. So I will get a slice of video that has 20 seconds of video. And this will basically how we'll be combining the images, the clips with the audio. So I'll get the audio and I will do the voiceover of the audio with this. Actually, I will do the voiceover of the clip with this audio here. So I'm getting the audio from the scene and also the clip that better represents each one of the scenes. In the same way, if there is a specific scene here that describes a scene on the middle of the video, that will be like a frame from the middle of the video that has like 1 minute. So I will get a slice of video of 1 minute and then do the voiceover combining this video here with the scene audio here to create the audio clip, which is this part here. So after I get each one of the clips for each one of the best frames, I do the audio clip creation, which is basically combining the video with the audio, doing like overlapping them so that I have like the audio clip, what I'm calling here. And that's also Python code, so it's quite simple. You can take a look later, but not a lot of very interesting stuff. What I found is that this movie py library was uh, super important to make everything easy, both the clip creation and also the manipulation with of video and audio. This makes everything much easier. After I have all the audio clips for each one of the scenes, you can see the logs here. So the next step, which is the final one, is quite simple. So I just order all of them chronologically and join them together, also using the same library. And then I get the final result, which is the number of trailer. So for this specific demo project here, I only generated one trailer, but the code is flexible enough that you can generate like 10 options of the video. So if you want to have options, it's also very easy to do that. And we can see here the final result, which is this file here on this specific path. I will play a quick, just a little bit of it so you can take a look. So this final part here, it paints like a good picture. You can clearly see the transition for each one of the scenes. And when it started to talk about the elephant, you can see that the similarity model correctly picks a good start for this scene, okay? Uh, and so after we have created our clip, I added a new section here that is why it shows why it's so important to have something like the context caching feature that we are now enabled to use with Gemini. So let's say that I'm going to create trailers for movies, but usually the first ones might not be so good. Maybe the trailer that Gemini created is not the best one, and I just want to automate everything. Maybe I take a few hours of my notebook. I just run this notebook here with a couple of times, and Gemini generate everything, and the rest of the code will generate many options for me. So if I want to generate many trailers, I will have to upload that very large video file many times, which would be like, I don't know, most of the prompt for sure, like 99% of my Gemini prompt will be only the tokens for the original video here that we saw that is 400,000 long tokens. So I want to have an efficient way to be able to query the model multiple times. And with context caching, I can do this. I can just cache the video there and ask Gemini to prompt it to create a new trailer different ways, which is what I have done here. So since we have cached the video at the start of the notebook, I can simply query Gemini again and generate another clip. So for this part, I have packed all the steps, the video creating pipeline, the trailer creating pipeline into a single function that you can see here. First, the creation of the trailer, improving the trailer, and basically all the other steps. They are packaged into the single function. So for the second attempt, I will just change the project name from the initial configs, and everything else will be kept the same. And then I can run the pipeline again with the function that I have shown above, and it will create a new trailer. So it's going through all of the steps and using the context caching of Gemini. My second round of prompts will be much, much cheaper and also much faster since I don't need to upload the video again, which you saw that took maybe 30 seconds or something like that. So it makes everything much more efficient. And this is the second trailer that I have created here. So you can see that it has created another trailer here. So the scenes are a little bit different. The text is a little bit different. And this one also looks very good. So I think you can get the idea here. With Gemini and also with context caching, I could generate like a bunch of different trailers, uh, both in an automated way that will be much cheaper and also much faster to do than just querying a model again and again, passing the video again and again. And finally, so that we can close here, I had a final section here that basically is doing the same thing, but with a different kind of video. So the first one was a walkthrough on a museum, which is quite good because usually the person will be going through the halls of the museum, and ideally each one of the scenes would be like different halls. So it would be like a clear separation of scenes for the trailer. But for the first one, I used a different initial video here that shows, let's say, the power and the flexibility, versatility of both my code project that I have created and also Gemini being able to process and analyze different kinds of videos that are also very large. And this here, I took this section, a keynote section from Google I/O 2024 that I had the pleasure to attend. And this one is the keynote for Google CEO Sundar. So I think this is one is a 20-minute video or something like this. It's available on YouTube. You can take a look if you want to see. So since I'm going to run this only once to show to you guys, I'm setting the cache here as false. But the rest of the stuff is basically the same. So I'm creating another uh, video file here that I'm uploading to Gemini. I'm instantiating another Gemini model AI Studio instance, since this one is it's not using the same cached file that I have set before, and then I can run the function again. So this one took maybe a little bit less, closer to 1 minute to upload. And after it's done, we can go through the metadata here. So this one is a little bit shorter than the other one, being a little bit less than 400,000 tokens, but still very, very large. So many of the other models, with the exception of Gemini, wouldn't be able to handle and process that data. And even if they are able to handle, maybe the results of the video processing wouldn't be as good as the ones that Gemini is creating here. So you can take a look here during the logs, the kind of scene trailer that Gemini created for my trailer transcript. And after all the logs is done, you can see here the final content, the video that was created. So yeah, the general transcript of the trailer was also very, very good. And you can see that the trailer is also somewhat aligned with the scenes. So if you want to take a look, maybe I mean, for sure, there are a lot of room for improvements, both in designing your prompt in a better way so the trailer is created. So we have two options here, two opportunities to improve it. One is at the first step where we create the initial draft of the prompt, which is this one. And also in the second step that we are going to improve that trailer. And also, if you don't like very much this library of text-to-speech model, you can like plug a different one as new models are released. Ideally, you would be using like a provider like Google Cloud text-to-speech model that we can have access through Vertex that has very, very good results. And also there is some improvement opportunities using another similarity model that can help better handle multimodality of linking the scene text with the images sampled from the video. So I hope you enjoy it. If you wanna give it a try, please do it and let me know what you think. Also, any kind of feedback and improvement opportunities. See you.